Yeah, but when you're able to start it up, they'll come in the middle of this blather, which is fine. Because don't worry, you might want to say when you say this, don't worry, you haven't missed anything. So
all those words, and I'll get there.
Anyway, iFixit says that you're losing your rights to take stuff apart.
Yes.
And part of the problem is the Digital Millennium, never mind what I think C stands for, Digital Millennium Copyright Act. Let's skip the hyperbole, at least for now.
No peeking.
And that's one of the things, that there's actually this principle, this first sale principle that says if I buy something and it doesn't do what I want it to do, I can alter it or reverse engineer it or do any of that stuff to decide.
If you buy it with a license, you're not buying the thing, you're buying the license to make lawful use of this thing as the terms of the agreement you sign.
But that's the principle that most people buy things like cars and laser printers and so forth. The idea that a laser printer toner cartridge can be intellectual property and you license the toner cartridge, and if you're refilling it, you're violating their intellectual property.
It's not what it is.
Bit of a
What government says that it is.
bit of a stretch as far as I'm concerned.
Government says that tomato is a vegetable because that is the higher tax rate, and so tomatoes are vegetables.
So they have a couple of examples here.
Isn't it what the company told the government to say?
Well, thank you, yes.
Exactly.
Government.com.
They use this to do it.
Well, it's because they need to be reelected. Like, you are born dying. When you are elected to office, my God, I only got 2 years to live. I need to raise cash.
So they have some examples. They have mobile devices, ebooks, cars, and coffee makers. So apparently,
Oh, we do the refills, yeah. It's like the print.
apparently the new generation of Keurig's coffee maker will not brew from a unlicensed Generation 2 K-Cup or whatever they're calling it. And if you dick around with this, as many have chosen to do, you're violating their intellectual property rights.
They're gonna cut you off, cut your caffeine off.
No.
I think they're gonna cut off more than your caffeine.
They used to say Keurig will give cover
That's
for
what it is.
greater bills.
As with the ink re-inkers, nobody's gone to court yet. And they probably won't. They'll all be settled out of court.
Yes, it's all
Because
this.
it will not survive court.
Right.
And
Exactly. So what you're seeing is this.
correct, you're being threatened, and they're instilling fear in you. And
Yeah,
that
terrified.
works every time.
Yeah, don't make fun of me, I'm terrified.
So what's the fix?
Well, you fix these folks at iFixit,
Yourself is the fix.
these folks at iFixit have asserted that they want to change the Digital Millennium Copyright Act to fix this problem. And
We have
unfortunately,
intellectual property problems in this country.
well,
And
I
they
think
need to
that the
fix it, but they won't.
I think that the biggest one is that individual creativity is not the thing being copyrighted anymore.
Correct.
And that is what copyright and patent law were intended to take care of at the very beginning, in the freaking basic Constitution, for crying out loud.
Yes, 60% of most contemporary conservatives actually want to disband the Constitution. They don't believe in the Constitution anymore.
Well, they say they do.
That's
They
so.
say
What
They
what
say
do
they're
they
upholding
think?
the Constitution.
What do they
but they're
think
not.
that they're conserving then, if it isn't constitutional government and the rule of law?
Freedom.
They want
Yes.
they want the opposite.
All right. I'd be willing to question that number at some later time offline. It seemed like it seems like a really goofy number. Anyway,
Isn't it the case that with IP law, patent law, as long as you can do your own version or basically replicate it, as long as you don't go into business. So,
No, you will be in trouble even if somebody that you give it to sells it.
no, what I'm getting to, don't give it to anybody, just do your own.
Oh, that has always been the case.
So many people did their own. There's cartridges, coffee makers.
Except for with moonshine. The people that were doing it themselves were selling it too, but no, the federal government went in and tore down all the stills.
no,
Not all of them.
not all of them.
They're still.
It depends, you know, if your last name began with a K and you still happen to be in another country and you're just bringing it in by boat, you didn't have any problem near as I could tell.
Correct. And
Let's just call him Joe.
we did not have good customs
Customs enforcement, yeah. Well,
back then. Now we do.
it was
Now-
good in the sense that you could pay for the level of customs enforcement that you desired
Correct.
as a consumer thereof.
Correct. Nowadays, they stopped the satellite broadcast chips, the satellite decoder chips. They stopped those. They don't exist, but they do exist. It's real technology that you can do it. They don't come in this country. And now we have that enforcement.
Well, Disney died many years ago, but you know, his works will be copyrighted for as long as they can make money off of
Why do you think
Mickey
they
Mouse.
redistribute?
there was
Redo.
there was at
Everything.
least one senator, I think he was the senator from Disney. Never mind where the folks were that elected him.
Just remember, like Disney's cryogenic capsule, you're right, that copyright is going to go on and on and on.
Okay. They did not freeze Disney. They just suspended his animation.
Was he one of those freaks?
There was actually an urban legend that he was cryogenically preserved.
Oh, just so you know, if you live in Anaheim where Disneyland is, you don't buy electricity from like PG&E or whoever it is.
No, you buy it from the mouse.
From Anaheim.
Well, we do the same thing in Santa Clara.
And Palo Alto.
Santa Clara.
And Palo Alto.
Yeah, that's because there are companies that say, we're number one on the electricity.
They have established monopolies, and the government has said that is okay. In certain cases, like utilities, they have local monopolies, because they consider that not general monopolies.
Oh.
And the federal government, the FCC, I think, is in control of that, and they have said they have not stopped this. Now, last week's decision by them was finally wonderful. They've made the internet a utility. But that's is merely a pause in the providers until they figure out how to monetize it.
Yes, exactly. In the end, we're all gonna have to pay.
Oh, no matter what they did, the rates are going to go up and the service will go down.
Yeah, the pay is not the problem. What to me, it's the amount.
Oh, you mean the bandwidth, right?
Well, that too.
Yeah.
How much you pay for what we get. I mean, look at South Korea.
Oh, yeah. They made sure that their infrastructure was based on fiber.
Yes. And
No, not just fiber, but you're looking at 100 megabit to the per.
Yes, yeah.
And they don't pay.
Per custom.
And they don't pay. They pay like, I guess it's $20 a month for that. Yeah.
Holy.
Where's this?
South Korea.
Not going to move there. Sorry.
It's not a man, it They leapfrog each other every couple of years. So,
It depends on who's,
Like-
did the latest upgrade.
yeah, Japan only offers 70 megabits per second. Only.
So George was talking a little while ago about installing a different copy of Antique Windows on his machine. I just wanted to point out this exciting article on How to Geek to find your product key.
Oh.
So-
Cool.
That's important if you do want to know how to install Windows.
But I'm sorry, I don't understand the people that want to live in the past. I don't understand that. I want the latest and greatest.
Complete with all the bugs and
Of course.
problems and
It's better than the bugs in the past that they already found and fixed.
that.
True, but so long as it isn't Windows.
Well,
I run the door.
I've run Windows since the beginning. I do not mind it. I know it will break. I rebuild it frequently.
So I wanted to point out that to this day, you could go to eBay and buy a copy of, George isn't listening. He's the audience for this.
You went to eBay and you're already getting ready to buy this.
Yeah. I wanted to point out that various copies of Windows XP are still available if you have software that is compatible with.
Oh, trust me, that's a really big thing.
Drivers.
Oh, yeah, I'm working on something called EtherCAT. You want to know what that is?
Yep.
Okay, EtherCAT, right? It's kind of called backup. They are a Windows house.
Right.
I tried loading backup stuff on the company laptop that I have. Guess what I found out? Oh, sorry, your network interfaces are not compatible. Okay?
Yep.
We have to end up using a, like 2 generations ago, desktop computer running XP
All right.
just at least for it to work. And I'm going, what the hell's going on here?
Did you go home automation?
No, this is not home, no, this is production type.
Yeah, factory, yeah.
Yeah, it's semiconductor manufacturing equipment. Yeah, and I just go, why? You know, that's why I wanted to say, let's start, for at least testing our new ETCAT devices, let's try Linux. It's a little better. There are things that are on there that will do that. And,
As long as your device, the difference is that when a new device comes out, the Windows driver will be written first. Most of the time, sometimes Apple driver.
right,
That is specific to Apple,
yes.
not a Unix or Linux driver. If you wait long enough, if it's an old enough device, you'll have a Linux driver
Right.
that will mostly work,
Oh,
not full features.
oh yes, I have. That's the thing. It's this thing called simple open EtherCAT masking.
Yes, you'll find an open source
But
driver.
at least I can functionally test this stuff.
Correct.
When I need to do performance, I'm going to need a specific EtherCAT driver where the stuff operates in the kernel.
Yes.
Yes. That's what I'm saying. I feel like I fell through the looking glass.
Well,
And I'm going,
yeah.
and I'm going to land in a big pile of rabbit raisins. I don't like rabbit raisins. They don't taste good, and they smell.
But hasn't that always been the case? It's been the computer industry since the very beginning. Yeah. Okay.
I said, it's just, but I get to learn a new language, C#.
Oh.
And .NET.
I'm
I
sorry.
wanted to use Python.
I have wondered.
Python has an interface with .NET, called Iron Python,
Yes.
which I mean, this kind of harkens back to the early days of Industrial Revolution where you had these guild that made iron, you know, and the way they were able to distinguish one another is they wore this iron cod piece shaped of a python. That's what they can tell, but oh my God, it's that's like I say, I'm counting the weeks until I can retire. Then I can pull a Johnny paycheck, press my bare ass against the glass.
Okay, that's an image.
Yeah, right here. This is the one, right here.
Fourth main page.
Huh? Yeah,
Mm-hmm. Too much information.
Yeah.
I know. I'm frothing right now.
You just triggered the TMI.
But that background, I went to they had
Yeah.
that's what-
Yeah.
just kind of showing all the
They show it, but their documentation is very bad. I mean, they don't even have to get it started, but you can actually use.
well, they really want, well,
They want to, they're like,
use everything they have.
Right.
They don't want to use it.
think of them as a mob. I mean, you know the name of the president of back office.
So is everybody up to speed on the story? Or can I go for 2 minutes about it? Okay. When you talk to your bank, you and your bank have what's called a secure link. And there's passwords and cryptography, and you say hi, and it turns into stuff, and then it comes out hi on the other end. Let's call this me. This is the Bank of America over here. I don't bank there anymore. I don't think. Yeah, one never knows. They may have my social security number for an entirely different person, but that's a separate issue. We exchange this stuff, and it's all encrypted and stuff. On the other hand, if you bought a Lenovo computer in a certain span of time ending fairly recently, on your machine, there was this thing called Superfish that inserted a proxy in here. And it took your password and said, I'm the Bank of America, here's your stuff. And it was, you were talking to the proxy. And the proxy had another conversation going on with the Bank of America. It didn't change anything that was going in either direction, but it could look at all of it because your proxy encrypted things that your password encrypted things that were going to your key, encrypted things that were going to the proxy, and the proxy had its own key with which it was talking to the Bank of America. And as far as you knew, unless you were kind of clever about looking at your link and saying, wait a minute, this key wasn't issued by, who issues keys? Who's a key issuing authority? VeriSign, thank you. That was the name of the company that I was looking for. Instead of coming from VeriSign, these keys were coming from this silly ass piece of software running on your own laptop or desktop machine. Which is all well and good if all you're doing is, well, I'll slip a few ads, I'll watch what goes by and I'll slip a few ads in and, you know, tell statistics about how you use your computer and things like that that made this company able to do business. Unfortunately, everything you say over the interwebs, no matter how important or secret or whatever, if it's protected by this SSL technology, it is now an open book because the secret password to this little box was relatively recently, let's see if I can find it, the key phrase, stored in the SuperFish software's active memory and trivial to extract. So pretty much anybody could get into your pants because everybody who was interested in knowing it could have the secret password to this little box. So that's the story of SuperFish. Yes, it's a man-in-the-middle attack. Exactly right.
So Lenovo put it in?
Yes.
Yeah.
It was just.
So actually, the intent, they say, the actual intent was to interject advertisements on every website that you went to, including HTTPS.
But it was done without any regard for their customer security whatsoever.
Yes.
Item. Maker Fair is Maker Fair will be May 16th and 17th at the normal venue. It's going to be their 10th year. And today is the last day to take advantage of the early bird ticket purchase. So, so if you're planning on going, check it out. Prices will increase starting tomorrow. That is all. It's on the third Saturday and Sunday.
Are you feeling like you want to blather a little? Imagine. So, okay.
Slather with a V on top of it. Sorry. Blather, rinse, repeat. I need my bathroom. I don't think I have it.
Here's a dongle.
There's a gum. Oh, perfect.
Oh, not at all.
Potentially.
Or as it says in Hitchhiker's Guide, mostly harmless.
That's a description of Earth.
Yes.
That was upgraded from harmless. The first revision. The first edition.
All right. I'm on talk. We have video.
Better?
Oh.
All right. My name is Sam Falvo. For those who don't already know, I suspect everybody already does. And I'm just going to give a really quick update because this is completely impromptu concerning the Kestrel 3. And basically, as some people might know, I now have a functioning assembler. You can see some assembly code here. This is, I'm in the process of writing a machine language monitor for the Kestrel 3 at the moment. And this is the cold boot point. This is where the processor actually starts up. I'm not actually going to go and do a code walkthrough on this, but I am going to give you an idea as to what the code looks like and how the code layout works. So basically what we have on Oops, why did you not work on me? So what we have here is on the left-hand side there is our source operands. We have two columns typically. We have, because it is a 3-operand architecture, so we'll have, for example, this is a register that always holds 0. This is another register. Some instructions do only take 1 operand, such as branch instructions, things of that nature. But generally, you'll have two items on source. And then on the and then on the right-hand side, we have our destination. So basically, here I'm loading from register S0 offset 0 because it's a indexed offset. We're going to store it into register A0, and we're going to load byte unsigned. So basically, it's fairly traditional RPN style assembler, but it is for a 3-operand RISC. And this is just a quick preview of the code as it currently exists. And the nice thing about this is I'm using this to actually build a Kestrel 3 emulator. Let me make sure my stuff is all up to date, which it is. So now if I attempt to run it, voila, we actually have software. And right now it doesn't actually do anything except echo back whatever I type in on the keyboard. But you can see, let me zoom that in here. But you can see it signs on, and this MLM K3 for V1, that is actually the banner for the machine language monitor when it actually starts up. And kind of pertinent to that, I have a blog article which I just recently posted, and it's called STS V2 Evented or Not. And basically, long story short, basically I got into an interesting conversation now that I'm actually writing the machine language monitor, and people are actually noticing, hey, you know, there's software coming out for this mythical homemade computer that doesn't exist yet. That people are asking, you know, will this be an event-driven architecture, or will it be a more traditional DOS or CPM-based, you know, operating system? And my initial intent was to just go with the simplest possible thing that could possibly work, which is just a CPM-ish type of operating system. But I had like 5 people actually come up to me and say, you know, we really want an OS that is built from the ground up around events. And when you look at the success of Node.js, and when you look at the success of Twisted, when you look at various other eventlet-based systems, or G-Event, or however, you know, libEvent, libuv, there's a plethora of event-based systems out there for Unix-based operating systems and you talk to the maintainers of these guys, and every single one, without exception, always basically says, yeah, we wrote this library because Unix sucks. We wrote this library because the architecture of the operating system doesn't let us do what we need to do. And it's a fundamental roadblock to handling 10,000 connections, you know, on a laptop class piece of hardware. So a lot of the people who have expressed interest in the Kestrel and its software evolution have basically asked, well, you know, can you please at least consider making it an event-based system? So that's what I did. I've considered it. And this blog article basically goes into lots of detail about what would be required of an event-driven operating system design. So here's an example of a very sequential, typical program. Asks your name, and then it says, nice to meet you, and it you know, prints that out. The important thing to remember, though, is that this call, this input name here, is a blocking call. So, which makes sense because you can't continue the rest of the program unless you have the person's name in hand. But if you have a completely asynchronous, completely event-driven operating system, that doesn't happen. What ends up happening instead, well, actually, let me scroll up here because I'm jumping ahead. So we'll print out, hello world, what is your name? But then we have this more complex blob of code whose sole purpose is to schedule the input operation, at which point we then return to an event loop of some kind. Now, the event handler, in this case input, uses this more complex initialization here as its workspace. So in a sense, it's almost like you're building an activation record for this input routine manually instead of relying on your compiler to do it. And in some respects, that kind of sucks. But in other respects, it actually opens up a lot of interesting possibilities. For instance, I could actually schedule several calls to input using separate blocks of memory that would all run essentially concurrently. So from the user's perspective, it's indistinguishable or maybe even faster than cooperative multitasking. But the important thing to note, though, is this callback here. This callback equals print name. Well, here's my print name function down here. What I'm basically saying is once the input handler is done with its buffer, it needs to know what to schedule to handle that data. And the purpose of that callback is to communicate that intent. So now press enter when the buffer is full, which you'll see later. We actually will explicitly schedule that event, and that's how control transfers here. And you'll notice here that all this stuff is all dynamic memory, so you have to free your resources and such. But the idea here is, even though this is a slightly more complicated program layout, I could conceivably run hundreds of thousands of these on a machine not much more powerful than a Raspberry Pi.
That might do things like login. Different example would be a login.
So the question is, could potentially include logging in multi-user capability? Absolutely, yeah. So there's a couple of implications to this. One is that the shell interface, when you type in the command on the shell, no longer is a subroutine call. It is an event dispatch. And this is kind of an important consideration because you load the module, asynchronously, of course. You find its entry point, the initial event, if you will, and you dispatch that. And it's interesting because it opens up the possibility that everything runs basically in the background. So as soon as you type in the command name and you hit enter, imagine seeing the prompt again, just right there, ready for more commands, which I can see benefits to that, and I can see how that could be a little bit more complicated than necessary, but we'll see what happens. But if you can imagine, like in Unix, if every command line that you type in implicitly had that ampersand at the end for background processing, that's kind of what it would feel like. Yes?
Can you talk about what advantages this might have in embedded application?
Embedded application advantages. Yes, the biggest advantage that this would have by far is your stack usage would be virtually non-existent. So on a processor like a Z80 or maybe an 8080 or 8088, you wouldn't necessarily, this may not have as much of an advantage, but on a CPU that either has no explicit stack like most RISC processors, or on a CPU that has virtually a very tightly controlled stack like the 8051 architecture or even a 6502, where your stack is limited to 256 bytes at most, this would be a godsend. And in fact, for anyone who is who has used a Commodore 64 back in around 1985 or so, you may remember a little operating system called GEOS. Right. So that is a completely event-driven operating system by design. When you actually run a program in GEOS, it launches the first section of the program code and treats that as an initialization code. That initialization code ends with an RTS instruction to return back to the event loop. So everything in GEOS is all event-driven, and that's kind of the architecture that I'm describing here. That's correct. It stands for Graphical Environment Operating System. So here's a hypothetical implementation of our event loop. Everything here is written in C because I wrote this at work and I didn't really have time to think about how to lay it out and forth. But this is all pseudocode anyway. In reality, I wouldn't even write this in C. I'd write this all in assembly language just to make sure I've got full control over everything. But basically, the way the event loop works is if we have nothing, that is to say, if our work queue is empty, we have nothing to do, and we don't have any quit flag, and I'm assuming that this is a global variable of some sort, then we halt the processor. This is kind of important because in an event-driven system, like right now, I'm not touching my computer at all. There's no visible activity going on the screen. There's no visible I/O going on except for video output. What work is the processor doing in real world terms? Not a whole lot, right? So you don't want the CPU to sit there and spin, because if it's spinning, that means it's consuming power. So this is another advantage for embedded applications, is power management. The less you have the processor spinning, the less power you draw. Yes?
Like point out a note there. There's a fallacy in debugging embedded systems that do halt. Because the debugger stops.
If it's internal to the device. But if you have something like a JTAG.
Through the JTAG ones, the JTAG is in JTAG specifically, the clock on JTAG shuts off and you lose your debug connection. It's fun to get back past that halt.
So you could replace that with a busy loop.
That's what you have to do.
Right.
That's the point.
Right.
Is for debugging, frequently have to remove those halts.
Right. So the concern that was brought up was that for debugging purposes, while you're debugging the kernel, for example, you'll want to remove the halt instruction. I would argue that there's a way around that, but I'll get to that in a bit.
Good.
Which is because this is your key. While the queue, basically just never have an empty queue.
That's another thought. If you can accomplish that, depending on your embedded system.
Well, you put the debugger in there and it'd be the only thing that would be running.
Mm-hmm.
Exactly.
That's what you want.
Yeah.
Is your debugger is the only thing that's running.
Which I'll get to because I think of this condition because on the Kestrel 2, the keyboard interface adapter, or actually everything on the Kestrel 2, there's no interrupts on the Kestrel 2 because the CPU doesn't have an interrupt input.
You're in the same position there.
Right. So I have to busy loop on the Kestrel 2. But anyway, let's kind of move on from there. But let's say an interrupt happens. Let's say that somewhere, somehow, you've got an I/O request queued, say for floppy disk or whatever, and you finally read that sector because floppies, right? Yeah. Reasons. So I don't know. It's the first device that came to my head. So you read somehow from a floppy disk or hard drive or what have you, and you get that interrupt. Now you know that this I/O request is completed. What do? You've got the data in the buffer. Obviously, you have to schedule code to work on this data, right? So that's what you do. And that populates that work queue. So after the halt comes back, queue empty now becomes false, and we fall through to this chunk of code. which basically says while the queue is not empty, we'll pop the queue. So we now have an event in our hand. We set a flag that says that it has not been scheduled because it's no longer on the scheduling list. And I'll explain that in a little bit. We do our callback on this event. So now we actually call the handler for this event. So now that we've got our buffer from the floppy, now we're actually processing it during this call. And if it's still not scheduled, we'll free the event so that we can reuse it for other things later on. So here's our hypothetical input routine from above. I won't go too much into detail here because, as you can see, it's a fairly lengthy bit of code. It's not hard. It's just that each chunk of code is handling a different edge case, if you will. So for example, here we're handling the edge case that we're overrunning our buffer. Here we're handling the edge case that we haven't read a byte yet. This is interesting. Remember that flag that I pointed to you? Here's a system call called reschedule. So basically, this is where I say, okay, I'm not yet done, so I'm going to reschedule myself for later. And that will set that scheduled flag because it gets re-added. And so we'll know not to free the event at that point. That's kind of important. And similarly here, if we press the enter key, we know that we're done with this buffer. And here we're actually calling the callback, or scheduling the callback, I should say. And you'll note that we return right away. So the interesting thing here is you are telling the kernel, yes, I want this thing to run right away. Or, pardon me, I want this thing to run at some point in the future, but it doesn't have to be right away. And then likewise, there's the rest of it, supporting backspace and other editing and such. So now we get into the issue of device drivers. And here I make the connection with more classical operating systems, such as CP/M or MS-DOS, and also classical Unix. Not so much Linux these days or BSD because they're based on a more sophisticated model now. But classically, you have two entry points. You have a schedule input that takes a request and figures out what to do with it. So in the case of the floppy disk again, you know, my head could be at track 0. I want to read somewhere in track 40, but we also have another write request or what have you all the way out at track 80. So do I tack it at the end of the existing queue where the head has to sweep all the way to track 80 and then go back to track 40? That would be a waste of time, especially for a device as slow as a floppy. So it makes more sense to intelligently look at the queue and say, okay, you know what, I think I should go in the middle here. And that's actually, that's kind of what the elevator algorithm is all about. But the interrupt input, or the interrupt entry point, is what takes those queued requests, those queued tasks, if you will, and actually says, okay, I'm done with this. Let me now schedule this and kick off, you know, whatever application is waiting for this. Well, that's kind of the same architecture that I just showed for general purpose events, right? So I kind of make that association. And so this is essentially the event loop, or the event handler, I should say, for what I'd mentioned earlier, that the keyboard interface adapter. Basically, up in this chunk of code, you would do a poll, and then in this, instead of just returning, you would reschedule yourself, because in this case, you have to reschedule yourself in order to keep polling. Otherwise, you end up not doing that. If you end up with only this running, you'll end up with what is equivalent to a busy wait loop, where you're basically just constantly polling, polling, and polling. Termination of a program is kind of interesting, because if we look at the end of that program at the very beginning, you'll notice that, you know, well, it's nice to meet you. We print that out, we free up our resources, and then we return to the event handler. But how does the event handler know that our program is done? It actually doesn't. Theoretically, if you have some handle to your program, you could actually kick it off again by sending it a new event. So there has to be a way to to handle that as well. And not only that, but let's say that you've got this long-running process. Some brave soul decided to port Photoshop to the STS environment, and it goes off into the weeds, and we lose our ability to control the program. What is our equivalent of kill-9? How do we do that, and what's involved? Well, in order to really truly kill it, not only do you have to remove and unload the program from memory, but you also have to kill all of the pending events that it has as well, right? So here we actually, for the first time, actually take a look at our event structure, and I talk about how you have to add that program reference. So basically you do, in database terms, it would be, select from event queue where program equals X, where X is the program you want to kill, and then remove all of those events. And that will essentially terminate that program. In terms of actually ending the program, there's another kernel call that you can issue called unload. And unload would be responsible for doing that for you. And that's basically, and then from here on down, it's all just refinement of what I'd already talked about. So here's like a complete hypothetical program that more or less does the same thing as the Unix command head, which just prints the first X number of lines of code. Well, in this case, I just print the first X number of bytes, but the idea is, we print out some stuff, we do our argument checking, we open our file, and then we schedule we schedule an open. Once the open happens, control resumes at this part of the program, and so on and so forth. It's actually fairly easy to read, fairly easy to understand. Here's an interesting case study, though. I'm actually scheduling an async read and immediately thereafter an async close. So the nice thing about this is we can't guarantee in which order events from different programs run, but we can guarantee that events from a same program will run in the order that you add them because it's a queue, right? So this will actually cause the file to be read, and regardless of success or fail, we always close that file. There's no if this, then do that, otherwise blah, right? So here's a case where asynchronous programming actually simplifies program flow. You don't care if it succeeds or fails, we just want to close the file when we're done with it. And then the rest of it kind of falls into place as you could pretty well imagine. So, in terms of software complexity on my side as an operating system writer, there isn't a whole lot. The event handler loop is it. In terms of complexity on the application writer, that's where you start to see the complexity involved. But I think the opportunities that this allows is kind of interesting. So I'm willing to explore this. So the next version of STS will probably be evented instead of threaded. And when I get to the point where I do add threads and processes and things like that, we'll add support for background threads and processes. That will have a more traditional synchronous API, of course. But we'll definitely keep the evented architecture as well, because there's applications for both. So that's my current update, and I don't know how I'm doing on time, but yeah, that's it. Yes.
So you're presupposing that you're going to have essentially the main event pump, and that events will be handled in order that they're put into the queue, and there's a single pump, basically. So, I mean, obviously with a single core, that's fine, but what about multi-core?
So STS stands for Single Tasking System. And it has always been intended to be a single tasking system. If you are running multiple cores, even with a threaded, even if you run strictly one thread per processor, this model breaks down immediately. And if you talk to anybody who's like doing Node.js or Twisted or whatever, they will tell you the same thing. Event-driven architectures do not automatically, like, this is something that Glyph likes to say a lot in his prose. Event-driven architectures do not automatically upgrade your code into fully multi-threading, fully concurrent software. You still have to deal with locking. You still have to deal with, blah, blah, blah. What this does is it allows a single core to be used to 100% efficiency. The reason multi-threading, and the reason they say that this is significant is because historically Unix and POSIX, whenever you change processes or change threads, a huge amount of work goes into the kernel to do that. You got to copy buffers into and out of user space. You've got to save and restore your registers. Like the RISC architecture has 32 registers and integer registers. If necessary, if you have an FPU, you've got to save and restore 32 floating point registers. If you have hardware specific registers, you got to save and restore those. And then there's the cache hits, and then there's the TLB reloads. Just a huge amount of overhead. Whereas the event-driven architecture is just, as long as you can keep those event handlers clean, it keeps things just moving along very smoothly and very, very fast. The reason why I didn't initially want to do this is because on computers like the Amiga, where everything is single address space and everything is kept minimal anyway, the overhead that you have in POSIX threads and processes and things like that just doesn't exist. The whole operating system itself is built around asynchronous I/O, around messaging and signaling and things like that. And that is indeed the model that I will go when I develop MTS, the multitasking system. That will be the successor to STS. But for now, for single threading, this will work fine. And if you attempt to run this on a multi-core system, the best thing you can do is run the event loop on one core and run threads on the other cores. And then that way there you can coordinate, and that will allow you to maximize your system. Oh, sorry.
I agree with you.
Yeah.
Event-driven is the way to go.
There's person number 6 who says event-driven is the way to go.
Event-driven, trust me. every place I go to, I say event-driven. My God, you think I was speaking Swahili with a Scottish brogue. They look at me. I was thinking that's a universal cracking several pieces.
Yeah. And the other thing too is, this may be significant historically for other reasons. Even if this doesn't actually take off. And when I say this, I'm referring specifically to STS and or the Kestrel. But this is kind of significant for another reason. As we saw with Kevin's earlier presentation about Superfish and all this other stuff, and about how you can be sued for just opening the case of whatever it is that you buy, we're seeing increasing pressure from commercial industry and from government for open hardware licenses. And I want to make this absolutely clear. The whole reason I started the Kestrel back in 2007 is because I noticed right then in a way, and I was right, is that when you buy a computer, you don't own that computer. You don't own it. You owned an end user license agreement. If you actually inspect the motherboard, if you buy a brand new motherboard, yeah, you've got the hardware in hand, you blah, blah, blah. Look through the pamphlets that come with that, and I guarantee you one of those is going to say end user license agreement. Absolutely guaranteed, especially if it says that it supports Intel UEFI.
Yes.
So the whole reason for the Kestrel is it is an open computing platform. The whole reason I adopted RISC-V, well, the initial reason I adopted a stack architecture is because no one was commercially interested in them except for green arrays. And so that pretty much guaranteed that it would be open source by definition. But now that we have the RISC-V architecture, it's 64-bit, it's BSD licensed, and it's guaranteed to be open for life because of that. right? So Kestrel is open, right down to the microarchitecture. And that will always be the case. I'm not looking to get rich quick. If it happens, you know, I would be very appreciative, but it's not like an overarching goal. I'm not doing this to get rich. I'm doing this because I want a computer that I can own, that I can open up the case to and say, huh, there's a bad capacitor on this. Let me swap the capacitor and not fear getting sued. You know, that's what I want. And so that's why I'm working on the Kestrel. So Kestrel may not be the computer for you in terms of operating system choice. You're free to port Linux to it if you want. It's not something that I'm interested in, but if somebody else wants to, by all means, please. There is in fact already a version of Linux for RISC architecture. You just need to update the RISC-V CPU that the Kestrel uses in order to run it. But it's doable. All this stuff is open. Anyone who's interested can download my sources, can download RISC-V's sources, unify the two, and run Linux on it. Right? This is something you can do today if you want to. But I'm not interested in running Linux because Linux is too complicated for me. I want something that one person can understand, from transistors all the way up to operating system level code.
Like you
Yes.
said, about, my phone here. So if I wanted to root it, you know, the warranty expired.
Mhm.
Okay, big deal. I'll wait till warranty eventually will expire. Then, you know, jailbreak it all I want.
Mhm.
But the whole idea, because a lot of I've never even downloaded an app to this thing. And I cut back on all the things that report information back to Google. Well,
Mhm.
I don't even have a Google account. What? We're all done. Marvel's being naughty again.
You're on the list just because they know that you're not communicating back.
And it's like when I want to pull a Johnny paycheck, you know, I can always do it to the local, you know, Google thing and, you know, press certain parts of my body against the glass.
Yeah, fingerprint this.
Yes. Yeah, find the minutia on here.
Yeah.
One of these days.
Really. VPs.
So yeah, so that's my current update. It took a lot longer than I expected, but then again, Dr. Ching still hasn't shown up, so I hope he's okay.
Anybody try to get a hold of him?
No. How about email through me? Is that it?
He's on the SVFIG mailing list, and I know my message went out, so
Well, he had sent his desire to speak via email.
Yeah.
I had sent him okay, the announcement is up with his schedule on the announcement. So stuff might have happened to intervene.
I was
He is retired from this.
Yes, I know. I was looking forward to his talk on.
You're so weird.
Here, you know, my degree, astronomy.
Yeah,
I
I get it.
All I'm doing is working with integers. I don't really do some science that you know.
You mean this isn't science?
No, not you guys. I'm talking like at work, you know.
Engineering.
It's, you know, it's engineering welfare. You know, I'm not working for, you know, the board. It's more like I'm working with a bunch of pathways.
Hey, this is
Sarcasm.
yes.
This is really cool. But the last part, talk about user agreements.
Mhm.
Again, there are a lot of kids right now. So a lot of kids are jumping in and they're learning how to play with interfaces.
Mhm.
You know, there's a lot back here.
You know, it's funny you mentioned that, because the whole point of Raspberry Pi is to get kids into computer science and maybe even computer engineering and such. And everything on, and most things I should say about the Raspberry Pi is open. But there's this one critical component that isn't open, and that's the microcontroller that runs the whole show, right? So when Raspberry Pi 2.0 was announced, someone from the audience raised their hand and they called on him, and they handed him the microphone and they asked, will we see a Raspberry Pi with a RISC-V processor at the core? Boom. I want to make this very clear. RISC-V has not been public for more than maybe 9 months. We don't even have real silicon yet. And there is huge demand for RISC-V right now.
Yeah, because see, with all these coder academies and all these things popping up, it'd be great to start not really one.
Mm-hmm.
Say Raspberry Pi, that's one.
Right.
People starting to.
Yeah, and the Kestrel is aiming to do that, do exactly that. My vision, when I explain this to someone on an elevator, is a Commodore 64, maybe 128 if you really want to get technical, a Commodore 64 with the user port available so that you can do hardware hacking on it, a Commodore 64 Programmer's Reference Guide, one book that describes everything from timing diagrams to CPU and hardware registers all the way up to the OS. One book. Imagine both of those available free. Just download it from GitHub. Just do a git clone Commodore 64 and boom, you have a C64. That usually blows people's minds because they can't envision that. But that's the goal that I'm shooting for. I will probably need help for the technical writing to write the PRG for it. But yeah, that's what I'm looking for. I want, and of course, the other nice thing about STS is because I do have experience with Amiga OS and how it handles disk flushing, buffer flushing and stuff like that. You don't go to a start menu to shut the damn box down. If you want to shut the machine down, hands off the keyboard and mouse for like 5 seconds. That's the cue to the operating system, flush buffers. Once all the drive activity stops, you just flip the switch or you pull the plug. That's it.
The pull plug thing is kind of scary. I work with oscilloscopes that if you pull the plug rather than press the off button,
Yeah.
it may necessitate a very expensive trip to some repair facility.
Well, I would argue, yeah. I mean, I would argue that either that or the power supply is not built for that.
It's just a crappy design, if
Yeah.
I may say.
Always push. Why do we need this big display unit on your oscilloscope when all you need is the analog electronics that reads what the probes are connected to, does all that stuff, and send it over a USB 3 interface to your computer, which then has a display.
Because the problem is that you want to use your computer for your computer stuff, and you want to use your scope for your scope stuff, and you don't want your scope to be any more complicated or hard or interfered with than it has to be.
Oh, that's what I'm saying. That you have a window that's your oscilloscope stuff. You have another window which is your computer stuff. You have another one which has your web interface. Because this, like what you're saying
Isn't for
pulling a
looking,
plug
it's
onto your
for doing
oscilloscope.
calculations. You want to be able to read that stuff electronically. And the only thing
Oops.
Oh yeah. So I don't know if everybody's heard it on the stream, but we're talking about digital oscilloscopes and sending data over USB 3 and such, and how the purpose of the data is for computation. And if only Dr. Ting were here. Well, for those who aren't aware, Dr. Ting's has an interest in inexpensive digital home-built oscilloscopes, and virtually every fourth-base processor project that he's worked with has involved the construction of a homemade digital storage oscilloscope. So that's why people were laughing on that. I think, did you have a question at one point? If you did, you probably forgot.
Yeah, but even you brought up this, you mentioned the new technology, ended with 5. I live under a rock, so.
That's okay. RISC-V.
Risk 5, yeah.
So if
What
you,
is it?
so, okay, so you're familiar with RISC processors at all? Okay. So back in the early 80s, late 70s, what's that?
I played with GA144, so.
Okay, so that's MISC, that's minimal instruction set. So back in early 80s, late 70s, Berkeley and Stanford both were involved, and IBM. All three of them were building a processor architecture that could execute a lot of instructions really fast by the internal of the processor. And Berkeley in particular had released their designs to the public under the name RISC-I, meaning it's the first instance of the RISC architecture. Since then, they've released RISC-II, and then they've released SOAR, Small Talk on a RISC. And then there was one that very few people ever heard of called SPUR, which I don't even know what that stands for. I'm guessing the R stands for RISC, but other than that, I have no idea. And then they just kind of faded away after a while because, you know, MIPS had already, you know, Stanford had, their design became the MIPS processor architecture, and then IBM took their System 800 architecture and released it as the IBM PC RT, and then from the RT it became the Power architecture and the RS6000s and, you know, Power PC nowadays. So you end up with these, you know, very commercially successful processors and such. And now, of course, we have ARM. But the problem is none of these processor architectures are open in the sense that you can't just arbitrarily add new instruction sets to them. And this is something that Berkeley was interested in and has become increasingly interested in over time, especially now that multimedia is becoming a thing and vector processing and such. So they're like looking at all these options. They're like, well, gosh darn it, you know, I sure wish we could add a custom instruction set to ARM. Or gosh darn it, I wish x86 were simple enough that we can write a damn compiler for. Or, you know, they had this huge set of wish lists. So finally, Dave Patterson, one of the guys who invented the whole RISC concept, and a bunch of his students said, you know what, screw it. Let's just do it all over again. So they looked at the MIPS architecture, they looked at PowerPC, they looked at Spark, and all these other things. And they said, what do we like from these? What do we don't like from those? And blah, blah, blah. And they released a new design. Only this time they were smart and they applied the BSD open source license to it because Berkeley was like, once we get actually producing live, and they have, they actually have produced live silicon, but they're research processors only. So they have proof of concept in actual silicon right now, 45 nanometer, you know, 1.2 gigahertz and so on. What they did was, we don't want to have to like set up and maintain this forever in perpetuity. So, and since that was Berkeley's 5th major of their RISC instruction set, RISC-V. Well, that's now their trademark, and they actually own the domain riscv.org. And if you go to riscv.org, that will actually do pretty much everything that's currently public about them right now. They also have a repo, and they've got Linux distributions for it, and all this other stuff. And yeah, so that's kind of the backstory behind RISC-V. And when I discovered that it was BSD licensed, I was like, that's it. That's the one I want. Because when you think about it, since it's designed, the instruction set itself is physically designed so that you can add new instruction sets very easily. I could very easily and trivially add MISC support to the RISC. So it could be a hybrid processor architecture if I wanted it to be.
Speaking of lunch.
Speaking of lunch.
It's raining out.
If you look, some of you may have noticed that it is raining at this time.
Yes, and there's a huge cell right over us. I'm looking at weather.com right now.
At the actual radar or at some interpretation thereof?
It's pretty good.
Yeah, my wife likes to look at the radar picture on the theory that she's better at interpreting it than people that have been doing it for 30 years and have their PhDs and stuff. But we digress. Yeah, there you go. One thought might be to just, I don't know how successful Pizza My Heart is in delivering on the Stanford campus. I expect they've got some experience doing it. Alternatively, we could just bite the bullet and stomp through the rain to the treehouse.
Well, it's gonna taper off in a few minutes.
Okay.
Is that cell moving?
It is moving, yes.
Okay.
Yes, I made sure.
So is that like 10 minutes?
That might be 5 minutes.
Okay.
Again.
So why do we do this?
prediction With it.
Why don't we? I'm just trying to get what it is he's asserting, so that I can base my plans on dealing with his assertions and folding it into my own prejudices. What I suggest we do is the following. It's like herding cats in this place.
Absolutely.
Why don't we wait 10 minutes, blather some more, wait 10 minutes, and at that point, walk to the treehouse.
That might be something we can do.
Yes.
Anyone seriously opposed, objecting, doesn't like it, unhappy? Say again?
I always ask for opposition.
That was what I was asking, yes. It's like the waitress comes and asks exactly the wrong question. She asks, are we all ready to order? And the question she wants to ask is, which of you putzes isn't ready now? Because all it takes is one of you guys.
Instead of asking, are you okay? Ask, may I help? I tell them that too, by the way. They'll ask,
Are you a qualified psychiatrist? How do you know?
I'm a qualified customer, and I don't want to give approval
No.
to her. I want to tell her what I want.
I'm just saying that in a store, someone will come up to you and say, I can help you now.
Excellent. Here,
And I asked that person, are you a qualified psychiatrist?
Yeah.
Why is your terminal set to an 8x8 font?
Okay.
That is the Commodore PET font from back in 1977. And I just
To be in the mood.
it's just easier on my eyes. I've tried Inconsolata, and I've tried a bunch of other fixed width fonts, and they all try to be fancy pansy, and it's like I don't want that. I just want like a nice readable font. So you can also get Atari ST fonts if you want as well.
And I always said, give the students enough rope to hang themselves. Sam, why don't you take a few more minutes and blathers?
Well, I think I'm done. I pretty much covered. Yes, this is serious. I've been working on the Kestrel now since 2007. The Kestrel 2, I should say, since 2007. And this is now the Kestrel 3, and it's only been about a year or so since I've sat down and actually spec'd things out and such. But yeah,
This is going to turn everything out there about getting kids and even older people who probably didn't, really take off. But they have, as you just said, you know what you want. And as you were just saying, Sam, the openness allows you to add whatever you want. And all that speaks to me, all that says to me is customization.
yeah.
That's what I want to do. I now have a platform.
So here's another blog article where I discuss how I came about designing the memory map for it. So the way it's laid out is I'm operating under the assumption that my Kestrel 3, the Digilent Nexus 2 board that I have, is one of 14 cards in a card cage. And the reason it's one of 14 is kind of explained here in this block of text here. So I won't go too far into it, but the idea is the upper nibble selects which card's memory space you want to read and write from. And when you bootstrap, usually those bits are either all zeros or all ones. So of the 16 cases, that leaves only 14. So it's geographical addressing. But then once you know the card, you want to be able to select which peripheral you want to address. So that's the next thing. And of course, that's card specific. I mean, you know, if you need 64 devices, then obviously you can have 64 devices. But then this gives me 67 million gigabytes of address space on a per device basis, right? 16 if I have 64 devices. Million gigabytes. Let that sink in for a while. Right. This right here is why I wanted a 64-bit address space, because I don't want to have to think about how to lay out a device anymore. It's like even in the emulator, I've got maybe 3 devices emulated. I've got the ROM, I've got RAM, and I've got the debug UART that I use to talk to the console. That's it. That leaves me with 13 more devices. So I have 13 times 67 million gigabytes of address space left for expansion. Yes?
Now, all devices are mirrored into that one address space.
Yes. That is essentially correct. I can. The comment that was made was that in one device's address space, I can map all peripherals that is manufactured on the Earth. Now, just to put this into perspective, this is for a 64-bit system, which I'm building. The RISC-V instruction set actually has support for a 128-bit architecture. No other RISC on the planet has that right now. With the possible, you can kind of argue that ARM64 supports it by register pairs, but that's cheating. Like you only have 64 bits of address space, whereas RISC-V actually gives you. But yeah, I mean, this is.
So this RISC-V right now is really a game changer.
It's utterly a game changer. It is such a game changer that the RISC-V folks. We noticed. We're talking about the rain outside. How it dwindled off and then it picked up. So the RISC-V folks wrote an article for EE Times, and I'll find the link and I'll post it to the mailing list. It is a well-written article. In fact, you can actually go to RISC-V, and it's linked. It's called The Case for Open Instruction Sets. It is a beautifully written article. Now, keep in mind that they're not saying that closed instruction sets are bad, necessarily. They're just saying that there's a case for open instruction sets as well. They're not singling out ARM, they're not singling out Intel, right? In that same EE Times publication, somebody must have contacted ARM and said, do you have a rebuttal for this? And so they wrote a rebuttal. And it was the case for closed instruction sets. And it was the most left field, it was like the most left field argument that you could make for a case for closed instruction sets. The best that they could do was backward compatibility. That was like the most solid argument that they could make. I mean, the RISC-V folks just laid the smackdown on them hard. I mean, and they weren't even trying. And the thing is especially when you get to if you really wanted to look at it, 64-bit RISC-V done in 5 nanometer process, which I think the reason they did that is because ARM7 TDMI was done in that process. 64-bit RISC-V pitted against a 32-bit ARM7 used less power and was faster at computation without any additional vector processing, without any, it was just measurably faster and it used less power. And ARM was pissed, horribly pissed. Yes?
I was just wondering if there's any implications in all this stuff for use of forth.
Yes and no. So when I first wrote the assembler, one of the first things that I tried doing was a machine forth implementation, because as you recall, I tried to do a 2-pass assembler and it just wasn't working, and my initial attempts at 1-pass assembly didn't work either. So I tried to port the machine forth that I used to code the Kestrel 2 in over to the RISC-V. And the answer is yes, it's doable, but you lose horribly on memory efficiency.
You may choose to make that sacrifice, though.
What's that?
You may choose to sacrifice that.
Right, which I was not willing to go quite that far. Right. So it is doable, but for something simple like a simple add operation, you're looking at 3 instructions maybe, which is about 12 bytes of memory, But what really killed it for me was handling constants. In other words, if I pushed a numeric constant onto a data stack, not all constants fit into 12 bits of opcode space, which is how you would encode small numbers. You would basically add it to the 0 register, and that's how you get that small constant. But if you have something that's larger than that, you have to store it in memory, and then you have to reference that off a base register somewhere. So you need a global pointer register. How do you initialize that? There's no concept of a global pointer register in MISC, right? And then on top of that, your compiler has to keep track of where the addresses for these constants are. And then to amortize the memory space, it would really be helpful to not duplicate the same constant multiple times. You can get away with not doing that, but then since you only have a limited range off of that base register, you really want to do that anyway. So you have to like keep track of interning numeric constants. It just added a lot of complexity. So I was like, yeah, I can do it, but the payoff is not nearly as good as it used to be.
That's very similar to the GA144. That's a event-driven machine.
Yes.
Absolutely event-driven. But it takes another machine to do the interpreter, to do the user interface. You have to have another machine.
Mm-hmm.
And there's where doing user input is not event-driven. It's harder.
Nah, I would argue that it is event-driven. It is actually what defines like the Windows event loop and things like that is all event-driven.
If you're I call it an object interface. Object interface is an event-driven system, absolutely. For the traditional fourth interface of a command line, it's not.
That's true. Yes. So
command line.
When you qualify it that way, that is correct. Because in order for the command line to work, it assumes that basically what ends up happening is the rest of fourth is event-driven and your command line is your event loop. That's essentially how it's designed. That's why it's called the outer interpreter, right? So whereas here you would have to invert that. You'd have to do a Jackson inversion in order to even begin to simulate that, and that's going to be a whole world of complexity unto itself. Quartus fourth for the Palm Pilot was built that way. And I remember getting into very heated arguments with the author about whether or not the command line for fourth can be properly implemented in an event-driven environment. And what it basically boiled down to was he had to implement his own background thread. He had to change stacks and swap registers in order to simulate the event-driven flow that Palm OS expected, which actually reminds me, not just Geos, but Palm OS is another pure event-driven OS. So yeah.
Gentlemen, I wanted to tell you that I had screwed up royally. I'm reading Ting's email proposing that he speak, and he starts off, I will try to attend the March meeting and talk about da-da-da-da-da-da. And I had completely skipped over
the March meeting
part of that. So we'll presumably have some bad mouthing of van der Waals in March.
Good.
Well, it's not presumed, let us hope.
But we had a great talk from Sam.
Yes.
For which we're duly grateful.
Thank you.
I suggest we bolt through the door.
Yes.
Shut down.
So I argue.
I guess it would be wrong to just look out the window and say, if we hurry.
I'm shutting it down.
We are heading to lunch, everybody. So good evening and or good afternoon, good something. You know what I'm talking about. We'll be back after lunch.